all paths from source to target. So we are giving a graph. So this graph is called DAG. So DAG is a directed acyclic graph. So this means there's no cycle inside this graph. So for example, from 0 to 3, you can always from 0, 1, 3 or 0 to 3, but there's no cycle. So the node is labeled from 0 to n-1, and we need to find all possible paths from node 0 to n-1 and return them in any order. So this means the path doesn't have an order. So we need to find all the paths, so that is okay. We don't need to make an order of the paths, because there's no meaning. So the graph is given as follows. We need to understand the data structure of this graph. So this graph uses an array to represent the graph. So basically, for most of the cases, there will be 3 data structure to represent the graph: adjacency list, matrix, and this kind of a 2D array. This means just from node 0, index 0, node 0 to node 1 to 2, and node 1 to node 3, node 2 to node 3. And this means this is so this means there's no node to this node. From node 3, there will be no outgoing node. We need to understand the graph like that, because this is a DAG, directed acyclic graph. So for this problem, first of all, we're going to think about the DFS, backtracking, because we need to find out the path. So for example, from node 0, we're going to backtrack, we're going to check. So the DFS would be 0 to 1, and the DFS would be 0 to 2, but at the same time, we're going to record the path, like 0, 1, and 0, 2. Now we find a 3, so we're going to record 0, 1, 3, and 0, 2, 3 at the same time. So this is a DFS. Another way is the BFS, it's the same. So for the DFS, we're going to find a path and then find another. For the BFS, we're going to find the paths all at the same time, layer by layer. So first of all, we got a 0, and then we got a 0, 1, 0, 2, and lastly, we got a 0, 1, 3, 0, 2, 3. So this is the BFS. The n is just 15. It means that this is going to be a very small number of the node. So normally for BFS and DFS, it can pass. Now let me try to solve it in DFS first. Let me define a DFS function. Let me analyze the time complexity a little bit, because basically we need to look through all the node with all the edges. So the time complexity would be v plus e. It means the number of nodes and the number of edges. So that is v plus e. It would be n squared. The time complexity would be n squared. That is why it can pass, I believe. So let's first try to use the DFS. So for the DFS, I'm gonna start from the first node 0. It is I. I'm gonna prepare a temporary result, because I want to put the answers inside the result. I also needed to prepare a variable n. It is the length of the graph. So the length of the graph, this means there will be n node inside the graph, but the node will be coming from 0 to n-1. Now I'm going to check. So if this I would be the last node, I'm going to put it inside the result. I'm going to put the answer inside the result, and I need a return, because if I find it, I'm going to execute the next DFS, next backtracking. So I'm going to check the neighbors. So for neighbors inside the graph, we don't need to turn this graph into an adjacency list, because it is not necessary, because this data structure has already given how to traversal the graph. So for neighbor in graph with this I, so this means we're gonna first traverse 1 and 2, and then 3. So for neighbor inside the graph, we can directly call the DFS. It's gonna be the neighbor and answer. This array would plus the neighbor. So in this way, we're gonna find all the paths. Now we need to call the DFS. it's gonna be starting from 0 and array, but inside we're gonna put a 0 inside, because from here we didn't record any 0 inside the path, but actually we need to have this 0, so I'm gonna call this function with a array, but inside I'm gonna give a 0 node. So in this way I'm gonna find 0, 1, 3, 0, 2, 3. So finally I just need to return this result. As you can see, it works. Now let me submit it. Now as you can see, it's pretty fast because n is a really small value. Now let me try to use the BFS to solve the problem. I'm still thinking about the time complexity. Is that right? I think it's not right, because from this node it can be many different nodes. It is not e plus v. It's a little bit difficult to analyze, because from this node, so for example, there will be 15 nodes, and from node 0 it will find like 15 different nodes, but it is a acyclic graph, and this one will find like 14, and the last one, it's similar like factorial of n, because we need to find all the different paths, but it should be less than that. Because like from this one, the first node, in total there will be 15, and we're gonna find 14. There will be 14 different paths, and after each of this one, it's gonna have 13. I think it is a 14 factorial. If it is not a big number, let me check the factorial of 14. This number is a really big number. So the time complexity should be less than that. I think it's just a graph traversal, but at the same time we just record the result. So the time complexity is just to traverse all the node. Just to traverse all the node. For example, from this one we go to this one and this one, and just to traverse all the node. So it is the e plus v. I believe it is e plus v. It is not factorial. Because we just traverse all the nodes. We didn't visit it 2 times, only 1 time. So it is the e plus v. Now let's try to turn this problem into a BFS. So for the BFS, we're gonna prepare a queue. So the queue would be the queue, and inside the BFS, we cannot put 2 data structures. Like we cannot put a node with array, but we just need to prepare 1 data structure array inside of the queue. Otherwise, Python does not support that kind of a data structure. I mean, inside array there will be an integer and there will be array. It is not supported, but we can use the array. So inside the queue from the beginning, I'm gonna put an array. Finally, if it meets the conditions, I'm gonna put the array inside the result, and then I'm gonna return this result. Now let me try to write the BFS. So while queue, I got an array should be equal to q dot pop left. I pop it out. So if array minus 1, it means the last node would be equal to n minus 1. I need to put the array inside the result. And then I need a continue, because this is a while loop. It is not BFS. Now I'm going to check the neighbors. So for neighbor in graph with this array minus 1, I'm gonna check the last node inside the array. Because I pop out the array, I'm gonna check the last node. while I put it inside what I needed to do, I needed to put it inside the queue. So queue needed to append this array would plus the neighbor. So the neighbor, I will give it a neighbor as an array because I use a plus. Yeah. And for this part of a BFS, we don't need to use the visited set. Yeah, because there's no loop. The visited set is only used to check loops. Also with the DFS, we didn't use the set. Yeah, because it is a DAG, we don't need to do that. And in this way, we're gonna find all the paths. Yeah, now let me run it. As you can see, it works. Now let me submit it. Yeah, as you can see, it's pretty fast, and it's much faster than DFS, because BFS, there's no function calls, because function calls always takes more time. But the time complexity is the same. We just need to loop through the graph, and after looping through the graph, we get the result. And for looping through the graph, the time complexity is E plus V, the number of vertices and the number of edges. Yeah. Thank you for watching. See you next time.